The thing is, the machine did not punch holes in them. So what you'll have to do is take out that staple and then hole punch it with a hole puncher. I think there's one back there. So guys, if you have your cell phone on your table, please remove it. is just to let you guys know if I see anything in those ears, if there's phones on the table, I will be taking off your points off your phone. Great. Ty, there's a phone in your hand. Please put it. All right. So we are starting a new unit today, which I'm excited about. And for our bell ringer, I kind of wanted just to do some questions on kind of how do bacteria get their names, since we're going to be talking about bacteria and antibiotic resistant bacteria in particular. If you guys remember from our lab we looked at a few different types of bacteria, or maybe like 2 different types of bacteria. One of them was really visible, being the Spirillum, the very spirally ones. That was like the really visible one that we were able to see. Bacteria come in those 3 different shapes. You have the spherical shaped ones, cocci, and then the rod shaped ones that almost kind of look like a pill. Those are bacilli. And then you have your Spirillum, which are that spiral shaped type of bacteria. So they are first kind of named just based on the shape of that bacteria. Next, you have growth pattern. So depending upon how they grow or how they multiply, they're going to grow or multiply in a certain type of pattern. If it ends with us, that's basically represents a single cell bacterium. So if it ends in us, it represents a single cell bacteria. So here we have a spherical bacterium, and so it's named as Coccus. So basically that would just mean it's one spherical shaped bacterium. If it's 2 together, that would be the diplo. Tetra is groups of 4. Strepto are chains, and Staphylo are clusters of those bacteria cells. And then bacteria, they can either be gram-positive or gram-negative. If you guys remember when we were talking about viruses, some have envelopes, some didn't have envelopes. Well, bacteria, some of them have evolved to have an extra layer around them, almost an extra layer of protection. And the way scientists find out if they have that extra layer of protection is by staining it. So they'll stain the bacteria, and if the bacteria turns out purple, that means it's gram-positive. If the bacteria ends up staining pink, that means it's gram-negative, and it has an outer cell wall covering of a lipopolysaccharide. So basically, being gram-positive, being gram-negative, the bacteria will stain a specific color, letting us know if it has that extra layer of the layer around it. All right, so the directions ask you to look at these 2 images, and then based on the information provided for you of the shape of bacteria and the growth patterns, what do you think the names of that bacteria would be, just based on that information? So for number 1, looking at this type of bacteria. So what's the growth pattern of that first type of bacteria? Staphylo. Perfect. So it is clusters. And since it's spherical, it's going to be Staphylococcus. Staphylococcus is the name of that particular bacteria. I also wanted to add in the fact that whether it had that extra layer of protection, if it was gram-positive or gram-negative, since Staphylococcus has no pink, it actually stains. It stains purple. It means that is a gram-positive type of bacteria. Gram-positive type of bacteria, which means it does not have that extra layer around it. For question 2, what is the name of this bacteria based on its shape, growth pattern, and gram stain? Who wants to try question number 2? What does the growth pattern tell you? So we have Strepto. What else? What's the shape? Rod. But what's the scientific name for rod? I feel like I heard you a little bit. Bacillus. Yeah. So that name of that bacteria is actually Streptobacillus. Streptobacillus, due to its shape and its growth pattern. And I actually put on the paper that it stains purple, but it actually stains pink. And since it stains pink, that means this bacteria is gram-negative. Gram-negative bacteria are going to be a little bit more difficult to kill. Anything that's gram-negative and has that extra layer of protection around it is going to be a little bit more difficult to kill than the gram-positive bacteria. So, I think this is just an interesting way to realize this is how bacteria are named. This is the part of the process of how they get their names. All right, so we're going to be starting Addie. Basically, this is a storyline that's going to help us kind of begin evolution. And while we go through this, we're going to be learning about all sorts of things. All right, guys, if y'all would just turn to page 1 of your packet. All right. And as you see, I did not put holes in this. I did not punch holes in it. The machine just didn't do it. So you can, in your own time, unstaple it, hole punch it, and then put it in your binder if you like. So lesson 1, we're going to be watching a video about a particular case in which this girl named Addie becomes sick. And we're going to kind of look at her story and dissect that. So while we're watching this story, you guys are going to be writing down important events. And you're going to write down any questions that you have after watching this. But it's important that you write down at least 3 to 4 different events that occur in this video that we are about to watch. So this is number 1 on your lesson that you have in front of you. You're going to be writing down important events and then any questions you have from this video.
Globally of some forms of bacteria that are effectively untreatable.
Each year, at least 2 million people are infected with drug-resistant superbugs.
They had asked me to sign the papers to let her go, and I did.
And at least 23,000 died from them.
He had some bugs that they had never seen before.
We immediately went on high alert, the equivalent of DEFCON 5.
No matter what we did, the bacteria was still spreading.
Frontline continues its reporting on how we got here.
In overusing these antibiotics, we have set ourselves up for the scenario that we find ourselves in now. We're running out of antibiotics.
The newest threats. Where did it come from?
We don't know exactly where this bacteria came from.
The economic realities.
There is an increasing recognition that antibiotics are not a good thing to run off a pure capitalistic market.
And what happens now?
A lot of what we're doing requires resources. If there is less money, there are tough choices that have to be made.
It could happen to your next door neighbor, it could happen to your child, it could happen to anybody. Those bacteria are out there.
Tonight on Frontline, hunting the nightmare bacteria. three seemingly disconnected events beginning at the same time. What they each have in common is a type of infection that is becoming impossible to treat. A type of infection that has triggered deadly outbreaks, even at one of our most prestigious hospitals. It is a crisis that is spreading alarmingly fast, threatening everyone, even the healthy. Our first story starts in Tucson, Arizona, in May 2011.
When I think about that time, I think about spring. And just how busy it was and how beautiful she was. She was 11 and a half years old and just physically perfect, beautiful from head to toe. Slim, white blonde hair from being out in the sun, a little bit of freckles across her nose, bright blue eyes, paying attention to what her clothes looked like and her hair. Never stopped talking, talked a mile a minute. That was Addie. That just, in the month before she got sick.
Journalist David Hoffman started reporting on the threat of superbugs for Frontline more than 4 years ago.
There's a warning from the CDC.
New and extremely dangerous.
Superbug.
Covering what government officials have called a nightmare.
It's a deadly nightmare bacteria. The CDC has called it a nightmare.
A kind of dangerous bacteria that is increasingly resistant to the strongest antibiotics. That's what brought us to Tucson, Arizona in 2013 to find out what happened to Addie Rarasich after she complained to her mother about a pain in her hip.
I thought, well, she's just finishing up softball. She had been to the track meet, it could have been an injury. I gave her some ibuprofen. As the night wore on, her pain got worse. She didn't sleep much that night. Woke me up a couple of times asking if she could take a hot bath or have another ibuprofen.
The next day, Tanya Rarasich, a nurse for 16 years, took Addie to a local hospital where they said she had symptoms of a virus. But over the next few days, the pain spread and the fever got worse.
I was afraid. At that point, I remember being very afraid. And so I packed a bag and we went to another hospital that had specialized in children's care. I remember thinking, she looks bad. This is bad. Something's really, really wrong. They put her on antibiotics. Her blood pressure was dropping. They, were making space in the ICU for her. The next morning, she needed oxygen via mask. They looked at part of her lungs and diagnosed her with pneumonia. I remember sitting there watching the sun come up and thinking, how did she get so sick? How did this happen so fast?
I met Addie in a hospital bed in the intensive care unit. She was lying there, breathing quickly. She was scared. She had little infected boils all over her body. What really looked most likely when I saw her was a staph bacteria causing septic shock. And Addie fit a pattern that I recognized with community-associated MRSA.
When you say community, this is what you mean that a kid picks it up in a playground with a scrape to the knee, right?
Correct.
The spread of MRSA, a staph bacteria that causes infections resistant to many antibiotics, has long been a big problem inside hospitals. But over the last 2 decades, it's also been found outside, in the community.
In Addie's case, she was a skin picker. She, as do many kids, picked at her little scabs. And that was likely what introduced the staph infection.
But the staph was just the start of Addie's troubles.
She already had evidence of an early pneumonia, and it looked like she was about to get a lot sicker.
I asked him what were the odds of her making it, getting well.
What did he say?
He said 30%, but he had to think about it for a minute, and I knew he was lying to me. I knew by the time your blood has bacteria in it, you're in real trouble.
The staph infection had so damaged her lungs, the doctors had no choice. To save her life, they put her on a lung bypass machine called ECMO.
I remember saying, ECMO? With a squeaky voice, like, no, really? You're not really talking about ECMO.
This was total life support.
It's got huge tubes that are put into an artery in a vein, and the patient's blood comes out of their body, runs through the machine, and the machine does what your lung does.
The tubes presented a whole new set of dangers.
Those tubes can harbor bacteria.
And one of the dilemmas of modern medicine. The interventions that can save you can also put you at serious risk.
Any patient we put on ECMO has a much higher risk of having additional infections. That's just the nature of the beast.
Is that what happened here?
Correct.
And she got a particularly nasty one. What was it called?
Stenotrophomonas.
Stenotrophomonas is an entirely different kind of bacteria from staph. Found in hospitals, it can live inside breathing tubes, and it's extremely difficult to treat.
The problem with Stenotrophomonas is, even at the outset, it's already a very resistant bacteria. There are only 4 or maybe 5 antibiotics normally that are able to treat that particular bacteria.
Addie was confronting the frightening new face of antibiotic resistance, a group of bacteria called gram-negatives.
So can you explain to me why these gram-negatives are so stubbornly nasty?
Gram-negative bacteria, it's a medical term, and it really references the armor that surrounds the gram-negative bacteria. That armor makes it very difficult for normal antibiotics to get into the bacteria and to kill it. So Stenotrophomonas is incredibly difficult to treat because it has that serious body armor surrounding it.
Are you guys going to come out and go that way? Okay.
The ability of gram-negatives to aggressively fight off antibiotics was now playing out in Addie.
She was first put on one antibiotic that's good for Stenotrophomonas, and it worked for a while. And then guess what? The antibiotic doesn't work anymore. Let's give her a different one. Well, and then it would, work. A couple weeks, 3 weeks, and then the Stenotrophomonas would sort of like bloom back up, rear its ugly head, so to speak.
You're doing great. You are.
Finally, one day, they said something I never thought I would hear. The Stenotrophomonas is pan-resistant. Pan meaning resistant to everything. Like a panorama.
Addie and her mother had entered the post-antibiotic era.
I had to go to her and say, I don't have options based on medical science. I've run out of options. I don't see a way out of this.
I remember a long weekend went by, and they had asked me to sign the papers to let her go. And I did.
There was only one hope left of saving Addie's life: to surgically remove the infection.
I remember asking the doctors then about lung transplant. They said no, that it couldn't be done, that it would be too dangerous.
The problem was that she was too sick to be transplanted. That sounds a bit strange because you think of a transplant as the final life-saving thing you've got. But because of that resistant Stenotrophomonas, the expected survival of transplanting her was not good. In fact, you might say close to 0.
You're not gonna blow bubbles?
Doctors faced a question of medical ethics, whether to risk such a valuable resource as a young set of lungs when Addie's chances of survival were so low.
What tipped the balance?
I think it was Addie's mom, Tanya, who was such a strong advocate and didn't give up.
Birthday to you.
And it was also the fact that this was not an unresponsive body lying on the table. This was a young girl who was communicating with us and had temper tantrums and sparks of life, which we could all see on the ECMO apparatus. I mean, how can you say no to this, living, alive human being who's communicating with you?
I need a high five. That's awesome.
But Addie would still have to wait in the intensive care unit, hoping to get a new set of lungs.
All right, so I'll give you some time to write down a few events, and then write one or two questions that you may have it. I'm about to pass around a sticky note for each of you to write on, and I want you to write one of your important events on that sticky note.
Disease, they had big words. Stereotypical something.
Yeah, but not a Netflix TV show. Y'all will find out eventually.
No, you do not need to put your name on your sticky note.
We need to see more about that.
We shall see. So now that you have your event written on your sticky note, what we're going to do is just create a timeline of events that occurred with Addie. So I'm just going to get you guys to come up here and put your event on here. Just remember, this would be earliest, so this would be before infection, and all the way down here would be to like lung transplant. So if I could just get Izzy and Anthony, Cole, and Riley, y'all come up here and place your sticky note where you think that is on the timeline right here. And if your sticky note doesn't stick, I have a piece of tape that you can go ahead. So just go ahead, put it up there, and place it in the area in which you kind of think your event occurred.
So the top is what?
The top is the earliest, so before she was infected. All right, now we can have Austin, D, Joel, and John. Who? You're not John. You are Philip. Colby. Sorry.
Right.
So cold. So close.
Yeah.
All right, we can have Mauricio, Jacob, Dewan, and Jalen.
But the thing is that, again, that's a whole human.
All right, we'll find out eventually. If you want to Google it, you can. Just don't tell anybody. All right, so Michaela, we'll have Ty, Aiden, and Gavin. All right, Jeremy and Gabe. All right. Okay, so let's kind of look at how this timeline looks. All right, so we have starting from earliest, she was a skin picker. Yeah, basically the doctor said that's really normal for kids to want to like pick at their scab. But picking at her scab basically opened up that first level, that first barrier. That skin barrier was then broken. Addie has hip pain that gets worse and worse as the night goes on. So she was a skin picker, basically. What was the name of the infection or the bacteria that got into that wound? Staph. So that was. So this is basically when she gets that first bacterial infection, and it causes her hips to start hurting. And then let's see, pneumonia. Yeah. So basically, was put on lung bypass machine to save her lungs. Right over here. She gets pneumonia in May 2012. The spread of bacteria caused her body to go into shock. So this is kind of more like a vague statement, kind of covering everything. Addie had to be put on false lungs, and that ended up making it worse. So Addie contracted staph. We'll put that up here. Let's see. She was put on machine lung. She was put on machine lung bypass. So a lot of the fact that she had the pneumonia, and since she was not feeling better, they had to put her on ECMO. She had caught more infection through ECMO. And that second bacterial infection she caught, can anybody try to remember how to say it? Say it? Stenotrophomonas. It kind of sounds like a Harry Potter spell. So this is where she gets stenotrophomonas. This is a gram-negative bacteria, so it has that extra layer of protection around it. And this is actually a bacteria that she caught in the hospital in that ECMO machine. It was in the tubes. Yeah, I mean, I just don't think I think it's basically impossible to make it 100%.
Why did they sterilize it?
They do, but they say it's just so much to kind of sterilize and for not one bacterium to make its way in it. It's still it's probably not as, looking at this video, it probably happens more rare than other times. Like Addie would be an outlier. Yeah, so it can happen. It doesn't happen all the time, of course, but it can happen. So Addie had a bacteria in her body and pneumonia, and they had to put her on ECMO. The mother was told that it could not be cured. What was the term they used for could not be cured, or basically no? Pan. It was pan resistant. So that Synatrophomonas was pan resistant. She got on ECMO. Are we talking about, I see somebody wrote virus being resistant to antibiotic. Are we talking about bacteria or are we talking about viruses?
Bacteria.
We are only talking about bacteria right now. You cannot treat viruses with antibiotics. You cannot treat viruses with antibiotics. The girl's infection became immune to everything. So yeah, her bacteria was resistant to that, to any of the bacteria or any of the antibiotics they have to date. All right, so there's just kind of our timeline of what went on. All right, so kind of just bringing this back to those bacteria again. So the two bacteria that Addie was infected with, the first bacterium that she got infected with was the MRSA, methicillin-resistant staphylococcus, and then the second bacteria was known as Stenotrophomonas. We know that the staph that she got, it was resistant to some antibiotics, but not all antibiotics. And let me move this thing. Was she infected with non-resistant bacteria? Meaning, did she get infected with bacteria that you think that could have been killed off by bacteria, by antibiotics? The only reason I bring this up is because there's this storyline where they talk about how Addie started to feel better, but then she would get worse. She would start to feel better, and then she would get worse. During those times where Addie started to feel better, what was happening inside of Addie was the fact that some of those bacteria that she got infected with that were not resistant, meaning antibiotics could kill that, that's the times where she started to feel better. Where the bacteria that could be killed off were killed off. But just the few bacteria within her that were resistant, once those started multiplying and multiplying and multiplying, then she was basically filled with those resistant bacteria. So here we have the first bacteria that she was infected with, staph, MRSA. It's a gram-stain positive. Resistant bacteria, yes, some of them were resistant, but we're not sure if all of them were. Stenotrophomonas was the second bacteria. She got infected in the ECMO machine, or she basically obtained that by the ECMO machine, and this is gram-stain negative. And this one happened to be pan-resistant. All right, so what we're going to do is, on your tables, you know how we used those markers before to do that little web map? So what we're going to do is, using those markers again, we're going to create a model. And I know for you, I haven't forced y'all to create a model yet, but you're going to have to challenge yourself. Creating a model is something that we're going to do a lot in this classroom. And it's going to help you understand events, processes, things that occur by putting it into a picture. By putting something into a picture is going to help better explain something to you. So in the space, basically on your table, you're going to draw a model that explains how Addie got sick better, then sick again, then a little bit better, and then eventually ended up getting very sick. What I want you to include in your model is Addie, bacteria maybe getting inside of her, antibiotics that she took, and some sort of change occurring over time, getting better or getting worse. So think about this timeline, and I just basically want you to draw images to reflect this timeline, to reflect Addie's story. And this is just some things that I want you to include. Some people's models are going to look a lot different than others. But you're basically just showing me Addie's story through pictures, arrows. Try not to write out a full paragraph. You could write a few words and then an arrow. But basically just draw out what happened to Addie. All right, so you can work with the person next to you to draw it, or y'all can each do y'all's own model, however you like. The colors are in the boxes, so either you can do your own model, or you can work with the person sitting next to you and y'all can create a model together. Yes. Yes, so get your clip and bring it here. Yes. You can draw stick figures. Say that again? Yeah, so basically you're illustrating
I'm assuming it's the bacteria. And upload your picture to Google. Oh, yeah, that's what it is. So we're drawing the model of like the bacteria and stuff.
Yeah, just basically it's a story written in pictures. And you can do arrows.
Alright.
So while she was running, you got a
As long as you can tell me her story. If you just draw one, I wouldn't know what's happening, you know?
It's from the track.
she just put one back. They have a bag over here.
We don't have enough space to do
It's done.
Let's like together.
What do you mean?
Alright, time for the final step. I do not know. On the draw two lines, the bump. Give her some 10. Hell yeah.
What was the position you were?
First one was staff, second one was stand. I can't read. Finally go to staff.
Can I take a picture of Yes.
Yes.
Hold on, I'll be right there.
Alright, then I got most of it. Correct?
Done.
What's the first thing you have to do? What's the second thing you have to do? I don't know where's that.
No, that's not that.
Yes.
It's not
Yeah.
was sitting.
So she got
ECMO, then she got sitting. And then, here's the storyline. So you got her, and you got the whole like scabbing. Had the infection. One infection.
Oh, think about ECMO.
Yeah, ECMO, the little disease. It's a file step.
It's everywhere. Yeah, I see what you're saying. Yeah, it's about the whole body. It's like you know how to get out.
And then Super Bowl right here. She's placed and then she cut her either. She got back here. They went home.
Very, I didn't understand this.
Right here. So it can get worse. They feel better. They get worse.
And this is kind of going this way, or?
Anyways, mom.
Okay, so she was just a minute and then infected with staph. That's supposed to be like bacteria. That's a good look. Took antibiotics, got worse, and nothing. This is like throat bleeding. And then she got diagnosed with extended pneumonia. And it got it in her bloodstream.
I appreciate you trying.
And then was the first bacteria.
Awesome, that looks great. I like the way you done that too. And the fact that you tried to do so. Like, Civic Group is
That's not throat. That's not throat.
Wait, what?
That's supposed to be a throat.
Yeah.
I was telling you that.
All right, guys, don't erase your work. Don't erase your work. I'm gonna give y'all about 3 more minutes, and then I want y'all. I'm gonna give y'all about 3 more minutes. Don't erase your work yet. So if you're done with your work, you could go ahead and sketch it on your actual paper. You don't have to. I won't take points off if you don't have the sketch on there. But if you are just sitting there doing nothing, go ahead and just sketch that onto your paper copy.
Is that right here?
Yep.
The work posted.
So what she's gonna do is she has to come to school with the packet,
Oh.
and then I post her lectures. All on
I told her it was a lecture. Oh.
So and then I'm starting the lecture right now. So then yeah, picture and then I post it on the Google Classroom and the agenda. Alright guys, so what I want you guys to do is, I want you to get up and go look at the other people's models, and I want you just to compare how their models look compared to yours. So go ahead and get up and you go check out other people's models that they had completed. I'll give you guys about 4 minutes to go check out everybody else's models, and then we'll come back to our seats.
So what's that? You got 10. Does that say? Yeah, that's it.
Right.
You could like
Okay, no.
I know, right? It's okay. Alright guys, looks like everybody's done. Please go and return back to your table. Alright, so if you would put your markers back into your box, and I'll pass around some wet wipes. Yes. Alright, so once you have your table wiped off, your markers back in the boxes, go ahead and answer question number 3. So right now you're answering question number 3 on your lesson 1.
Wait, I forgot all my partner.
What do we answer?
Number 3.
We can just put one thing.
You can, at least if you have similarities, one difference. If not
I mean, you're not wrong.
No.
That's the best part. You know, three.
It's still not a rag.
So, do you want me to take the rack out of this one?
No, if it's in there, it's fine. So no, I took that. So yeah, you did not need to upload a picture. Did not need to upload. Yeah, I have that up there. All right. So by looking at other people's drawings, people kind of go about these models a little bit differently. But as long as everybody's model kind of told the same story, that's what matters here. And basically putting that storyline into pictures, telling us the story of Addie through images, arrows, showing us that sequence of events that occurred. All right, so last thing we're going to do for lesson 1, and then we'll move on to lesson 2. I want each of you guys to write down one question y'all have about Addie, and try not to ask the question, "Does she die?" Because we will find that out. But I want you to try to come up with one question that you have, and tomorrow we'll actually go through each one of these questions. So try to think of one question, and then I will collect these and we can answer these questions tomorrow. Just kind of as a review.
Yes.
I think your dad left her. We didn't see your dad. We really did.
So right now, just write one question that you have. in your question, go ahead and put it on the Addie's question board. Go ahead and put your sticky note on the Addie's question board.
What's gonna do it? Oh. We might do it. Yeah, I'm always coming. Oh my god. Stop being there.
What's your question?
What do you think is going I didn't say how it's gonna go. Who is? I didn't write it. I spelled it. Oh.
What? Okay, but yeah, blame your question.
I have not done that though.
All right, guys, please flip to page number 3.
Can we read the questions?
We're going to do that tomorrow for review. All right, so lesson 2. How common is this problem? Can what happened to Addie happen to me?
Yes.
Obviously.
Happen to me?
Wait, it's so bad.
It's probably
Yeah, so remember how
I
you
got
the scab and then like
diabetes.
the bacteria would
Can't
enter
twice
the blood?
in that.
Yeah. So say if it was like a pimple and then like can that still happen from there?
Yeah,
So-
I already had it.
So
No.
basically what happens is bacteria, that's when she said she becomes septic.
Can't kill the
You have to have a very bad infection for bacteria to actually get into your blood and go everywhere. So like that would mean that would have to get infected. Like a pimple would have to get infected with bacteria. You know what I'm saying? Yeah. All right, so what are your experiences? Have you ever gotten an infection or ill, and what happened? Has anybody gotten really sick before and like had to go to the hospital?
No.
What'd you get? You got pneumonia. Do you know what caused your pneumonia?
I don't know.
But you've had to go to the hospital. That's pretty bad. How'd it feel? Like we couldn't breathe?
Yeah.
That's awful. I've never had that before. What about you, Colby?
I got a splinter and I had trouble breathing for like 3 weeks.
So did they tell you what you got infected with? Did they tell you what infection you got? Oh my god, you need to figure that out.
Don't lie.
No, you need to figure out what bacterium it was so we can talk about it. That's wild.
I also had pneumonia twice, so now I wheeze a lot.
I got diabetes, so I don't think bacteria.
No, that's not bacteria related, but yes, that is also a problem. What about you?
I had a respiratory infection.
How long ago?
That was when I was in April.
Do you know what caused it?
I honestly don't remember.
Yeah, it's hard to remember exactly what.
Yeah, but it was bad. Like I didn't go to school for like I think a month.
See, respiratory infections are scary because it can stop you from breathing, which you have to do every few seconds. That's wild. That's awful. So yeah, we've actually had quite a few people in here that had to go to the hospital due to pneumonia or respiratory disease or an infection. I personally have had staph infection twice when I was playing sports in high school. But could what happened to Addie happen to us? Jeremy?
Hey, brother. Hey, got the question?
Thank you.
Sorry.
Yeah, I mean, what happened to Addie is kind of rare. Maybe not the MRSA, but the Stenotrophomonas. That's more of a rarity than getting the staph infection because the statistics of actually catching Stenotrophomonas or pan-resistant bacteria on ECMO, I don't think it's that high, but basically getting an infection can happen to anyone, even us. All right, so we're going to be looking at reading 1. If you guys would turn the page to page 5. So looking at page 5, lesson 2, reading number 1. Here is just an infographic, and this infographic is telling us information about the threat of antibiotic resistance in the United States. Anthony, would you read the first paragraph for us?
Antibiotic resistance when germs, bacteria, / fungi develop the ability to produce the antibodies designed to kill them. Is one of the greatest global health challenges of modern times.
Thank you. So yes, they're basically defining what antibiotic resistance is. If you've never heard that term before, that is something we're going to be basically covering for the next month. And antibiotic resistance happens when bacteria evolve. And it's a major health crisis that we are all dealing with globally. So here we have some numbers below, new national estimate, and these numbers reflect patients in 2017. So each year, antibiotic-resistant bacteria and fungi cause at least an estimated of 2,868,700 infections yearly. And from those, you have 35,900 deaths that occur. On the right-hand side, they're talking about a specific disease known as C. diff, Clostridius difficile, is related to antibiotic use and antibiotic resistance. And in 1 year in the United States, there's about 223 cases, or 223,900 cases, and about 12,800 deaths that result from C. diff. And C. diff is something that occurs that's related specifically to antibiotic use and antibiotic resistance. So that's just kind of important information when it comes to talking about antibiotic resistance. So new antibiotic resistant threats list, updated, urgent, serious, and concerning threats totaling 18. So this just means that currently, at least in the year of 2017, there was 5 urgent threats, meaning bacteria becoming resistant, 2 new threats, and then 3 on the watch list about potential threats becoming resistant. Antibiotic resistance remains a significant one health problem affecting humans, animals, and the environment. Data show infection prevention and control is saving lives, especially in hospitals. But threats may undermine this progress without continued aggressive action now. So antibiotic resistance is something that's been happening for a long time. Anytime we give a bacteria time to kind of adapt, they're going to evolve eventually. So we have these bacteria that we keep giving antibiotics for. And what ends up happening is eventually those bacteria don't die anymore. They actually survive in the presence of that bacteria. And that's when they're becoming resistant. So here's the reading that I had for lesson 2, reading number 1. And what we're going to be doing and what you guys are going to be doing is claim, evidence, reason based on different readings. And I'm going to give you an example of how you're going to do this. So behind reading 1, you have reading 2, reading 3, and reading 4. You're going to be choosing 2 of those sources to annotate and to fill in the table for claim, evidence, reasoning. I'm going to give you an example of how to do this. So I'm going to basically use this first reading that we just went over and give you guys an example of what I'm expecting. So from this article, the claim, which is basically the main idea of the article or the results, the claim that antibiotic resistance is a major problem and a major global health threat. So that's the claim. That's what I'm taking away from this. What's the evidence? Well, the evidence that I received from here are that 35,900 deaths a year due to antibiotic-resistant bacteria and fungi. That's basically your statistics. Now, what's the one, that is a lot of deaths due to this problem. The number of deaths in the U.S. alone is higher than I thought. So basically, we're just connecting evidence to the claim of our reading. Yes. So I'm about to get there. Yes. So what you guys are going to do, each person will read and annotate 2 of the sources. From the readings, you will fill in the table below. After the timer is up, we will share our findings to the class. So right now, you guys can either choose between reading number 2, reading number 3, or reading number 4. They're all about the same in length. You're going to be choosing 2 of those sources, whichever ones you want to choose. You're going to, basically, the first source I choose to read and annotate will be reading number blank. You're going to put that number down. And then the first source I choose to read and annotate is reading number blank. You're going to provide a claim, evidence from your article, and then the reasoning behind it. You're going to be annotating 2 different readings. The only one you can't do is reading number 1. So you have to choose between either 2, 3, or 4. All right, so go ahead, start, choose your reading, and then start your claim, evidence, reasoning. Alright guys, go ahead and pack up. That's where we're gonna leave off for today.
Pack up.
And guys, just remember, please watch out for your phones. I'm taking points off every single day that I see your phone out. Dave, Cole, Ty, Anthony.
What notification is going on?
Alright guys, y'all have a wonderful day.
Yeah, because he didn't want to go. He did.
Good afternoon. Still morning. Like 8. Okay, no. Triple paper cut, bro.
I know. I saw that. I was like, already?
Yeah, it's a. Pencil, please. I believe you. I do.
Goodbye.
Whoa.
They're not his first name. They're not ask me.
It's gone. Yeah, I know. I saw it too. I was like walking and I said,
I'm watching
Please remove cell phones from tables, earpods from ears, and put your mask on properly. Yes, and take those AirPods out of your ears. Oh, yeah. It should.
I don't know how to read this.
So look at, yes, what was Friday? What the date was? Alright, so look at the 28th. It should not say anatomy and physiology. It should just be 8. As long as it has a bell ringer and a foldable. Quincy. All right, Quincy, I'm taking a point off your bell ringer for not returning back to your seat. Yes, ma'am.
do we just combine all the words together?
Mm-hmm.
Okay.